So, welcome back. Number 3, now that we understand what has to happen when we only know S, I'll be able to give you problems where I just give you data, right? Because now you can just calculate what you need. So take a minute, put that data into your calculator. Fantabulous data entry time. Bless you. And then where do you go from here to get to where you can calculate statistics? How do I get to where I can calculate the sample mean and the standard deviation? Stat? Calc? One of our stats. List 1. No freaky list. Calculate. Now, obviously, X bar, 78.286, roughly. What's the standard deviation?
15.74.
Is that right?
I'm using the sample one, but I think so.
Everybody concurs?
I believe.
Yes, good. All right, so the calculator, I always get students that are like, well, the calculator gave me sigma, so I can use z-scores and all that kind of, no, we're the humans. It gives us both because it doesn't know. It's a stupid thing. No offense, little dude. So we know it's a sample, so we know it's got to be S. I love it. So S is, get over there, 15.724. Okay, so now we've got that information. We can now figure out the 98% confidence interval. So let's see. We know X bar, we know S, we calculated those. So we know N, 7. And I think, oh yeah, good. What, is N big enough, by the way?
No.
What the shit? So are we allowed to do something? Yes, it was taken from a normal distribution, so it doesn't matter what the sample size is. It's already normal. Cool. Okay, so what's the one thing we don't know yet? T. What's the degrees of freedom? And actually, I kind of jumped the gun here. Why are we using a t-score? So 2 things. Yeah, I only know the sample standard deviation and the population is, or I mean, the thing is normal. I love it. Okay. So degrees of freedom, what's that? 6. It's always n minus 1 for these kind of problems. And what's alpha? 0.02. 2% outside. If there's 98% inside, there's 2% outside. So now look up what that t-score will be. Don't say anything. Let's see, 0.02, 2 tails. Stop at 6. What do you guys get? 314,311. Which is way bigger than what the z-score would be, because that's its job. It's just supposed to stretch that out a bit, catch more stuff to be more certain. So let's see, we got X bar, give or take, this many of these. One of the biggest mistakes I see is people divide by the square root of all kinds of things. That's got to be n. Whatever number's in there's got to be a whole number. If you're putting a decimal in there, you know you're wrong. It's supposed to be a number of things. N. It's supposed to be how big the sample is. I think the error is about 5.28. No, it's going to be bigger than that. 5.5. 48 divided by 316.
Error, I got 18 points.
Yeah, I'm not. Yeah, thank you. I forgot to multiply by 3.143, of course. So yeah, 3.143 times 15.724 divided by the square root of 7. Yeah, 18.679. And technically, you should put it to it. Sorry, enough decimals happening. Let me stop for a minute. Is everybody with what's happening? So this problem, I didn't give you the mean. I didn't give you. You had to actually calculate them yourself. Be really careful because on the screen it's going to show sigma. But if it's a sample, you can't use that. And now you subtract, and you get like 59 point something, right? 59.5, 603? 606? 6?
Yeah,
67?
607.
607? Oh my gosh, okay. And then when you add, you get up to 96.965? Sure. Now, considering this is talking about what the average grade looks to be, is that a very good confidence interval? Because that's like somebody saying, what's the average grade? Somewhere between like an A and an F. You're like, slow clap time for that shit, right? It's like, all right. So why is this such a pitiful interval? Why? Why is it a pitiful interval?
Doesn't really tell us much.
What's the very first thing? What makes this whole thing suck? It's based on a sample. Why do I sound like Jerry Seinfeld? It's based on a sample. How big is the sample? 7. All right. So it's based on not much information. So I really want it to make sense. So if I base this on 7 grades, of course my interval's going to suck because it's communicating to people, hey, I don't know much. That's what that's saying. The error was almost 20. I mean, forget about it. So if I had a sample of 70, wouldn't that make this much smaller? So again, that's another verification. The bigger the sample you take, the better things are. Okay, I like it. I lost a few people. All right. So here comes the exciting part. Oh boy. Oh shit. How many? I got 2, 4, 6, 8, 10, 12, 14. Okay, this might work. We'll see. We'll see. We'll see. I'm hopeful. All right, just look at this. Just glory in this other side of this. Look at that wall of data. This is true data, by the way. This is average grades up to this point in the semester for the last several semesters for teaching stats for my stats courses. So this is true data, but it's from like 4 years ago, but oh, too bad. I didn't want to sit down and update this one. So there's a lot of data here. So let's see. All right. What I need you guys to do. And by the way, did I say this somewhere? Yes. Normally enough. Randomly select 20 grades. When I say randomly, does that mean I'm going to select everyone that's got a 0.0? Is that random? Nope. Does that mean I'm going to select everything that's 80 something? No, that's totally so not random. What's one way to random? You drop your pencil and you look at it. You could even, what?
I was going to say, pick every, 10th grade, but then...
Beautiful. You could do a stratified. You could do systematic. You could do stratified, where you take some from every row or something. So take a minute. Everybody should have different data. Should be very unlikely anybody picks the exact same 20. Pick 20 data points and put them into your listing in the calculator. Go for it. I'll do it too. We'll all do it together. This is exciting. Okay. How am I going to pick? I don't know, Jeff. do it this way. It's going to be annoying, Jeff. Do that. And just do this. Oh.
How many are we doing?
20. Crazy sauce. This is exciting. 2, 4, 6, 8, 10, 12, 14, 15. Okay, we got a good shot. We got a shot. Just in case anybody out there is confused, you're not going to have the same numbers I do. I have picked a different sample than you.
Is there a way to undo something?
Yeah. Clear.
We're just gonna clear what it is.
Oh.
I don't know if there's a way to go back.
Oh shit, no. Sorry about it. Yeah, that's the one thing you can't do. Bring the data back. It's very unforgiving. Now everybody's got a different sample, but should anybody have a different t-score? Isn't everybody's degrees of freedom the same? Isn't everybody going to be 90% confident? Okay. So I'm going to do this work over here so I don't give things away. Ha, ha, ha. Here's the next exciting part for you guys. When you're done calculating your confidence interval, I want you to put what you found on the board. So everybody understand? I put mine up there. That's what I found. Let me see. Let me take you on a little trip. Take a little trip. All right, so there's the array of things. Cool. Now I'm really sorry I put them over there. Figured it would be better because it's not much room here. So you can't really see that board. Sorry. But two things to notice. Everybody got their data from the same set of data, but this is what freaks me out. I mean, look at this right here. I'm curious. I'm wondering if they got the same data. That would be really, 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 really unlikely. Not impossible. You guys all follow? Isn't this exactly the same outcomes here? Which is fine. There's nothing wrong with that. It's just really, really, really unlikely that people. How did you pick your data? Do you mind me asking?
93 all the way up and down till.
Oh, you just picked the first column?
I just went down the first column.
Okay. And is that what somebody else did? Yes? Okay. So that's why, I mean, technically it's just math. But, so random, you really want to randomize it. It's okay though. It's okay. Because that's a valid grouping of 20. So, and you especially wouldn't want to do that if the data was given to you in order. Because then if you did that, you would just get all but nothing but the lowest, right? Grades or whatever. Okay. Wide array of means and confidence intervals. The actual the actual average of this data is 80.297. I think there's only one, is that true? Is there only one interval? And again, I'm really, really sorry. I don't, there's not a damn, oh wait, these two didn't either, right? Okay, there's 1, 2, I'm gonna count these as 1, because they're the same data. So there's 1, where's the other one? Shoot, this one. 2. I think every other interval caught, and that's a little big, but okay. Every other interval caught the real mean. You guys see that? And in fact, isn't that what confidence intervals are trying to do? Right? Isn't a confidence interval trying to catch the real whatever? That's its job, correct? Everybody in here made 90% confidence intervals, right? So what percentage would we predict to not contain the real mean? 10%. Does that make sense? We're 90% confident, which means 90% of all the confidence intervals made would not contain the real mean. There are 15 intervals up here. 2 of them don't contain the real mean. What's 10% of 15?
1.5.
Rounded up to 2. Okay, now. I don't know if you guys are with me. This is so cool. I love this. There's so many things about this that's awesome. This is a concrete freaking example of different people taking samples, right? So of course your intervals should be different unless you have the same kind of like way you picked it, right? Is everybody with me so far? A 90% confidence interval means that 10% of intervals that are created the same way will not contain the real mean. We basically hit it almost exactly if I count these two as 1. Right? Yes, kind of following. So with a smaller group like this, it was possible that none of them, that all of them would have contained the real mean. Because it's only a 10% chance. So if I had 15, it could have been none of them that didn't contain the real mean. But I don't know if this helps enough. Okay, maybe. At the very least, it's a little more concrete example of the kind of problem I do sometimes give, where people can have their own samples. Yeah.
So the probability of none of us getting that interval within 0.1 to the 20th power? Right?
Oh, the probability that all 20 did not capture the mean, the real mean, would have been, yeah. Right? Is that what you're saying?
Yeah.
That would have been 0.1 to the 20th.
So there's only
Well, 0.1 to the 20th.
12% chance of all of us getting
There's what now?
Only a 12% chance of all of us getting that interval, or getting the mean in the interval.
So if you do 0.9 to the 20th, is that what you did?
Yeah.
Okay.
Would that be correct?
Yeah, yeah. So, okay. So it's almost guaranteed that at least one of them won't contain the mean. Are you guys at all with me? So that's what it means when we say we're 90% confident our interval. Why are we 90% confident? Because 90% of all intervals would catch the real mean. So we're 90% sure ours does. And some people didn't. Does that mean that these people made a mistake? Did these people make a mistake? Nope. They did everything beautifully. Perfectly beautiful. It's statistics. It's the most honest math. It's like, all that shit looks great. But, 10% chance you're wrong. Did somebody have a hand up? Yeah.
I was just gonna ask, so the answer for D would be no, because the interval, like whatever our interval is, catches the actual.
So for everybody who isn't one of the ones I circled, your answer to part D would be no. Because it like you said, your intervals catch 80.29. So for those of you that, these guys, your answer to that would be yes. Because your interval does not contain 80.29. 7.
What does that mean that the mean isn't 80.2?
No, I know, because I just fed all this shit with
Yeah.
Excel, and the mean is 80.297. This is the thing about statistics. These intervals are built on samples taken. Is it possible somebody could just happen to take a sample where the mean is, where the grades they took were all lower? Yes. Is it possible people could take a sample where the grades they picked were all higher? Yes. Because samples have random variability. You could just happen to pick really old people. You could just happen to pick people that scored really high or really low. So some samples will do that. I would not expect a lot of them to do that. Because what should happen more often, if you're randomly picking, you should randomly pick a mixture. Right? Okay, I love it. I really want to make sure, by the way, that the people that I've circled, there's not a damn thing you did wrong. It's just statistics. We don't know. If we're only taking samples, this is a weird case. We normally don't know what this number is. So why in science then, if one group studies something and sees something, why do I want to wait till other groups do the same thing? Because if these people are where I stop, I'm going to think the average is an 80. But in reality it is. So that's why I want other people to try to replicate that. Right? And that's why one big thing about science is sometimes the report results too early. Right? Oh my God, if you eat 20 eggs a day, you'll be, holy shit, no. Do some more study on that. Right? Maybe? Okay, all right. Hopefully that was somewhat useful. Let's see, how much time we got? A little bit, okay. So that's chapter 8, done and dusted. Right. T-scores, hopefully they're not too concerning. Okay. What we're about to do, I want to get like a little bit into chapter 9. And I just want to talk about the idea. We're not going to do too much nuts and bolts today. Does anyone have, let's see, what should I say? Yeah, so for example, if we went into this thinking, I think the average is not 80.297. 3 people would have come away saying, I have found evidence that it's not 80.297. You with me? Is that somehow wrong because the average actually is 80.297? Is the statement, I have found evidence that it isn't? These 3 here would say it isn't 80.297, yes? Because the interval doesn't contain that. So they say, I have found evidence that it isn't 80.297. Is that statement wrong, considering we actually know the average is 80.297?
No.
Definitely not. It would be wrong if I said, I have proof that the average is not 80.297. No, you don't, right? Do you have evidence? Yes. Can evidence point to the wrong conclusion?
Yes.
Which is why we try to do what? If we have one piece of evidence that points a certain way, what do we then do? Get more evidence. See if they all start pointing this, then I'm building a case, yes? So what we're about to get into, this sounds a lot like a court case. And what is it about a court case? You have to show that the defendant did something within a reasonable doubt.
No, wait, isn't that without a reasonable doubt? Is that how you prove it?
I can't remember.
Oh.
Within a reasonable doubt, right? So if you said, well, I didn't do it because the universe is a simulation and I've been programmed a certain way, so I shouldn't be held accountable, that is not within a reasonable doubt, correct? That might be true, but it's not reasonable to think that way. Yes? All right, maybe. So if anybody was thinking about using that defense, maybe you shouldn't, right? No, officer, I was not speeding. That's just what my program told me to do. All right. When we have a court case and there's a defendant, what is considered to be true? What is the assumption that we make when this court case starts? And I don't mean the court of public opinion. I mean, legally, what is considered innocent until proven guilty, correct? So that's why the entire thing is on the prosecution. They have to build a good enough case. They have to show enough evidence to point to a certain direction. Yes? Does that make sense so far? Okay, I love it. So when someone makes a claim, such as, I am innocent, right? And we think they're wrong, we're going to try to find evidence to show that they're wrong. I love it. We can't prove all the time that they're wrong, even if we have video evidence. I mean, what really freaks me the shit out is the deep fakes, right? Hello. And they got the deep fake face, they got the deep fake voice. I mean, my God. You can make anybody say anything. It's insane. What did I hear? Anyway, I don't want to talk about it. There's a lot of weird shit. A lot of weird shit floating around. Anyway. So, let's say we have a claim. Let's say we claim that this stats class is doing better than my last semester class. So let's say the claim is this stats class has a higher average than last semester. Now I know the answer to that, but I'm not going to tell you. Right? So, but in general, we don't know. So we try to figure out, find some evidence. So, what could you do to analyze this? This might be a weird one to work with, but let's say you somehow know who took some of the people that took my class last semester, right? What could you then do? Yeah.
Their average compared to.
Yeah, you could talk to the people. So you could take the sample that you know and get their average. Now, let's say, and don't I tell you guys what the average in here is? Don't I just give that to you? All right. So let's say the average, I can't remember what it is in here currently. It doesn't matter, Jeff. Sort of does. You're not going to find that page, Jeff. Yeah, you're right. It's on your grade sheet summaries, but here we go. Perfect. Yeah, it's roughly 76 right now. So we know U is 76 for this class. Can somebody tell me how to write this English statement in Mathish? Speak, friend, and enter. No.
Which one?
Numbers plus.
Numbers, I love it.
Which statement?
How to write this statement. Now that we know this, how do you write this statement in Mathish?
Use the right answer.
Yes, okay. So this that class has a higher average. So we would say this, and let me say this, mu now. So I worded this horribly.
How about mu of current?
Yeah, mu current. Yeah. So actually, the claim in Mathish, this is my fault. I really do a horrible job. The claim would be that last semester is less than us, right? So if I use mu as being last semester, the claim is that they had an average less than us. Let me stop for a minute. That's just my horrible. I decided to try to write things as well as the book does. Okay. Let me stop for a minute. So you're going to be able to find claims in English. They're going to be very clear. Most of the time it's going to say, Bob thinks that more than, greater than, right? Sally thinks that the same amount, the same average as equal, right? Same, equal. So you could figure out from the English, you could figure out how to write it in Mathish. What if somebody doesn't think so? What would theirs look like in Mathish? If I'm like, oh, no, it's not right.
Theirs would be mu current is less than or equal to, or no, mu past is greater than or equal to.
Yes, right? What's the opposite of this? Greater than or equal to. So in any claim that somebody makes, isn't there an opposing position to that? I mean, even if nobody exists that thinks it, isn't there an opposing position? So if I think that the percentage of stat students who go insane is 11%, the opposing stance is, no, it isn't 11%. Nah, right? Okay, maybe. By the way, that's true, so be careful. Okay, so I've always got two sides. And sometimes I think of this as two old men in a Starbucks arguing about politics. I don't know if you guys have ever been in Starbucks for a little while. You'll see, normally they got their newspapers out and they start arguing about stuff they're reading.
I can actually say I've seen that before.
There you go, thank you. You're about to enjoy this a lot. So these are hypotheses. You with me? These are hypotheses. There's two of them, yes? There will always be two of them. One we call the null hypothesis. H with the O. The little subscript O is like 0. And that's null is basically 0. It's sort of like just the original stance, assumed innocent until proven guilty. So the null is you're innocent. And you got to show evidence against that. So the null in this case, and then the other one, before I talk about which one that is, the other one, you're going to love this, is the alternate hypothesis. So I will affectionately be calling these the hoes and the ha's. And that's just the way it's going to be. But this is the null hypothesis. This is the alternate hypothesis. But just to refer to them quickly, the ho and the ha. Now we know so far. So anytime somebody makes a claim, somebody could hold the opposite thought. There will always be two kind of hypotheses at play. Right? Does that make sense by itself? Why we call them these things might not make sense, but the null is sort of like the original. We can even think of this as O as the original. And the alternate just makes sense. It's the other way of thinking about things. The null will always have an equal sign. So the null always has an equal sign. So here's the idea. What did we say the opposite was to this?
Mu
Greater than or equal to, right?
greater than, yeah.
Doesn't that, so here's 76. So the null will think it's somewhere in here. And to be more precise, it actually thinks it's up here. This guy thinks, where would that show up on the picture? Less than.
To the left.
Yeah, now, let me ask you this. If we take a sample and we get an average of 75.8, is that less than 76?
Yes.
If we take a sample and we get an X bar of 75.8, That is less than 76. Why is that not good enough evidence necessarily?
It is too close to 76.
Yeah, if I take a sample, isn't there going to be variability? So the whole idea we're doing here is I have a number that I'm fighting against somehow. I think it's greater, I think it's less, I think it's different, right? Or in terms of the ha, they're going to think it's different somehow. But in order to show evidence that's true, not only do I have to be less than, I have to be less than enough. I've got to pass all the stuff that samples would be the variability of a sample. I got to get so far away that the probability of showing up there is so low that this mean is actually smaller. So right now, there's a probability I show up in this table. Let's say it's like a 5% chance. Yes? If the mean really is 76, there's only a 5% chance that a sample would show up here. Is that cool so far? This sounds like we've done this kind of stuff before. If I get a sample that shows up in there, there's a 5% chance that would happen. And if it happens, what's more likely? That we just happen to get a bunch of really low numbers, or that the mean really is less than 76? What's more likely would be the mean is less than 76. This is only a 5% chance of happening. So what's more likely is the picture actually looks like this maybe. It's actually over a bit. So it should make sense that if somebody claims that something's less than something, the sample better be less than. But now, on top of that, based on everything we've done so far, it should make sense. Not only does it have to be less than, it has to be less than enough. It's got to be far enough away to go, wait a minute. Okay, maybe. Okay. So here, the null hypothesis would be greater than. So where's the claim go? Does this have an equal sign? No. So it goes next to the ha. The ho is going to be the opposite of that. So you write the claim down. If it has an equal sign in it, you put it here, and the opposite goes there. If it doesn't, you put it here, and the opposite goes there. These two are always opposites. Beautiful thing about inequalities, if one is pointing one way, the other is pointing the other way. That's an opposite. If one doesn't have an equal, the other side has an equal. That's the opposite. What does your gut tell you? Look at the picture I drew. Is this a one-tail or a two-tail test?
Two-tail.
In order to show evidence for this, isn't there just one tail I'm focusing on? To show evidence that it's less than 76, do I care about this side? I need to show up over here, right? One-tail test. So if I see a less than or a greater than there, it's a one-tail test. This side or that side. What's the only way it would be a two-tail test? Yeah, if it was equal to. If this is not equal to, what's not equal to mean? Less or greater? Two-tail test. Now you, again, I tried to say this earlier, but that's why the T-score chart has one tail, two tail. It is built for hypothesis tests. Yeah.
So the alternate can have an equal to
No.
sign?
Alternate, never. Null is the guy who thinks it's in here. Alternate will always be the one we can show evidence for. If I took a sample, real quick, if I took a sample and the sample mean was 76, is that evidence, is that proof that the mean really is 76?
No.
Is that even evidence that it's really a 76? Not really, because samples could be whatever the shit. So this guy will always be the statement I can show evidence for. It's going to be the one that's farther away. I can never show evidence that it actually equals something, but I can show evidence that it's different from something.
Can you show an example of a two-tail test? Because I think I'm having trouble like
Yeah, okay.
visualizing what it'll
Yeah,
look like.
so let me do another situation. So what if we claim, let me do a percentage. We claim that 48% of, I don't know, people like, what, Jeff? You can do it, buddy. You can do it. Like lychee. I think that's how you spell it.
Yeah.
I don't know where they came from. Do I have a craving for lunch? Is my body trying to tell me something? So what is that in Mathish? Be really careful. What is it in Mathish? What's the claim in Mathish? What are we claiming about? Are we claiming about an average?
No.
A percentage. Okay, so P. Am I saying less than, greater than, increase, decrease? Am I saying anything that's a directional thing?
It's just equals.
Yes,
0.48.
equals 0.48. Where am I going to put that? I'm going to put that next to the null hypothesis or the alternate hypothesis.
No.
The null always has to have equal sign. What am I going to put here? What's the opposite of equal to? Yeah, we used to put this symbol, these two symbols. But math people, we don't like two symbols together like that, right? If I had 7 plus -2, I'm just going to write 7 minus 2. Remember that? We don't like two symbols next to each other when you don't need them. So we do this. The funny thing is this symbol actually makes it clear it's two-tailed because it's up or down. How do you not be equal to something? I could be more than it or less than it. So this would be a two-tailed test. So again, if I take a sample and I get something in here, that's not enough evidence that the actual percentage is 48%. Because if the middle really is 0.48, and I take a sample, aren't I expected to get something close to that? Anything close to that. In fact, before chapter 9, and we sort of are still here because I haven't really opened this up. Where does unusual start?
2 standard deviations.
2 standard deviations away. So if I got any sample that was 2 standard deviations up, 2 standard deviations down from this, that is not evidence that I've done something unusual. That would not be evidence against this. If we got a sample out here or out here, that is evidence. Something unusual happened if that is the real middle. So what's more likely is that's not the real middle. So if we got something up here, then the picture might be skewed that way. Or down there the other way, right? Stop for a minute. This, by the way, is definitely one of the harder chapters because it just combines almost everything we've done. I'm not trying to make you feel anxious about it or anything. We're going to go through it. When I learned it, there were 8 steps to a test. Let me just do my whole walking uphill both ways. So when I learned it, there was 8 steps. I've made it 5 steps for you, okay? Because you only need 5 freaking steps. So we're only going to do 5 steps. And you're all like, that's still 4 too many. That's too bad. It's better than 8. Okay. This is step number 1, by the way. Right? Okay. But this is one that's got some new shit in it. We haven't talked about claims or talked about hypotheses or talked about 1 two-tailed test, so this is all new. The second step will be old stuff. Second step will be, can we use z-scores or t-scores or something, right? So that would be, is it normal enough? Which standard deviation do I know? In this case, for percentages, I'd have to look at NP and NQ. Yes? So step 2 basically is it normal and can I use Z or T or what, right? Okay, so that's old news. Step 3 will be related to figuring out what these are. What's far enough away? So going into this, we had 2 up, 2 down was always where unusual started. I kind of gave you, I think, at least one situation. Oh man, Jeff, you talk a lot. Earlier this semester, I'm pretty sure I talked about if you're in a nuclear reactor, right? And your job, you basically got Homer Simpson's job, right? And you're looking at the gauges and such, and this one's kind of like starting to move towards the yellow. Are you gonna wait until it gets in the yellow? Just got it. Wait until it's halfway in the yellow. Hell no! In that case, unusual might be 1 standard deviation. You with me? Because what's the consequences of me not acting early enough is everything blows up, right? In another situation, it couldn't matter, it doesn't really matter. So maybe then it's 2.5 instead of 2. So in chapter 9, there will be situations where our definition of unusual will be different. If I'm trying to prove to an insurance company that they should lower their rates because I installed some stuff, you with me? Do you think they're going to have a difficult to pass test or an easy to pass test? Difficult shit, yeah. They're going to be way up at 2.575, maybe 99%, right? They're going to be like, we ain't going to lower your damn insurance until you show me a lot of shit. Are you guys kind of with me a little bit? Okay, so it depends on what the situation is. That then unusual could have different definitions. I think that's enough. Okay, so laid some groundwork there. We still have several more steps to talk about. And I have a handout I'll give you next time that goes over each step.